going to. We're going to hear double things, but that is not that bad. So, but it is there because conditioning is very, very important for the pelleting process. So we can't emphasize enough the conditioning part. No, this one doesn't work. Oh, that's a pity. So yeah, unfortunately my lecture starts not very positive because I have to say magic doesn't exist. Some people believe that, some people know it's not true. They have a little bit more life experience, but it is. Like told before, conditioning is the key for the optimal process. And you can select the conditioning. We already heard 1 conditioner, 2 conditioner, there is even more. And if you don't select the right conditioning process, it's going to be very costly for you. So, we know why we need to condition, we just spent 10 minutes on that. But what is conditioning? Conditioning starts by grinding. The first step in your conditioning process, in preparing the product for the pelleting, is grinding. I'm not going to discuss that, that is already done by my colleague, thank you for that. But we're going to be a little bit deeper in the technology of conditioning. It's one side thermal and the other side is mechanical. Thermal by adding steam, mechanical treatment by electrical energy, how we measure that, by netting, shearing, compressing. The type of conditioning is based on the characteristics of the material. The starch, the fiber, the fat, they all have their optimal, unique way of getting processed. And this one is basically the most important sheet if you look to conditioning. What does that mean? If we have a high starch formulation, we take quite a lot of thermal energy and not so much mechanical energy. The more we move to higher fiber, we're going to start to add more mechanical energy. We're going to use less thermal energy, and even when we go further, we're going to increase again the amount of thermal energy, but the total energy processing is going to be much higher. And for every step in that process, there is actually an ideal way of doing that with different type of processes, which we highlight a little bit. So we start with just the simple steam conditioning for higher starch formulations. I heard already saying that you have to prevent that steam going up, it's superheated. But another thing in the design of your machine is very simple, of course, electrical energy by a direct drive. But there is also a possibility to have we call it a dynamic steam lock in your conditioner, preventing that the steam goes up. If you want to know more, you can come to the booth of CPM M058 in Hall 8. We skip this one for the time. But there are different ways of adding your steam optimally in the machines. We heard already about more conditioning because the more fiber you get, the more mechanical quality you want to put in. They want to longer conditioning times. How they started to do it with double conditioners, or if you want to have a higher liquid, people put an extra conditioner on top, and after that put a conditioner below to have enough retention time, and on top the high-speed conditioner. But that is not necessary anymore. those 3, 4, 5 stacked conditioners are only there because the traditional conditioners have not enough retention time, have not enough filling. So when we were looking in finding ways to get a more hygienic conditioner, we found out that the higher the filling you do, the more clean the conditioner stays. So we find a way to increase the filling degree to 70%, while a traditional conditioner, everybody says 30%. Well, if you look in the field, you maybe sometimes find as low as 15%. So when you go to 70%, that means at least 2-3 conditioners would be the same in the traditional one. So that gives all the benefits of a higher temperature, you have a better pellet quality, your hygienization, etc. How does that work? Because I say magic doesn't exist. Actually, the trick in there is that the pedals, the tip of the pedals are transporting the product to the front of the conditioner, while the shafts of the pedals are transporting the product to the rear. How does that come? Because the shafts, the pedal shafts are mounted in a spiral way, and the direction of the spiral is backwards. That means that the product goes forward, backward, and stays in, and you create so a longer retention time. But what is more important, the liquids are sort of polished by the material inside the product, so the absorption is much better. And then, last but not least, at the end of the line, when you finished your product, it doesn't look like this, the traditional one, because what happens is people like to increase the retention time by putting the pedals nearly, how you call it, square against the wall and not covering the wall. Here you see that the pedals are parallel to the wall. That means that they can clean it. And this is really true. This is not from the workshop. This is how the conditioner looks after a run. It's really amazing. When the first time the mechanic came back, the engineers came back after commissioning, they saw this picture. I don't believe it. I came to my customer, I opened the machine, and it looked like that. So they were not fooling me. One little thing, when you start, you want actually as quick as possible to go to your set point temperature, because then your pellet mill is operating ideally and it's more hygienic. How does it work? First, the conditioner goes in reverse. Then we add steam till it reaches the temperature, and we change the direction. So that means that the first kilo coming to the pellet mill is warmer. But what does that mean? That the pellet mill reacts completely different. You can go in 2 minutes to your set capacity. And with all the frequent changeovers we have, it means an enormous benefit. Especially also when you do hygienic feed, because the first kilo coming to the hygienizer needs to be warm already. So an hygienizer is not a very complex thing. It just needs to be built correctly to keep it hygienic. But it is just a big screw. Product goes in, first out, and depending on your RPM, you can go to the end. So that brings us a little bit to the pellet mill. And yeah, the pellet mill, we can also be quick, short. It just needs to run needs to run, make good pellets, because a pellet mill operator doesn't like to do hard work. It does certainly should not slip. So, but we were talking about energy. Okay, and energy must be consumed most efficiently. And we as feed millers have a responsibility to go to a sustainable, more sustainable world for our children, our grandchildren. So we need to provide the industry with the most energy efficient machinery. And we do that, of course, with gear motors to reduce the footprint as good as possible. We're talking about that energy. In the pelleting process, we have different materials we process. And each material has a certain amount of thermal energy and a certain amount of mechanical energy. Just like, for example, each product needs to be ground on a certain particle size. So the thermal energy you can adjust easy in the conditioner, while the mechanical energy you have in the die, and with the roll adjustment on the pellet mill you can start to adjust the amount of mechanical energy to put the optimal energy into the pelleting process. It's actually a very simple possibility to adjust the gap between the rolls remotely during production. It increases your pellet quality, I will show you. It increases your die life, it reduces your downtime and increases safety. But here is it what it really is. Here you see, by increasing the roll distance, you increase the amount of kilowatts. And with that, you increase the quality. So, by adjusting the roll distance, you increase your quality, or you adjust your quality. And that is very important. Now, of course, we all know, or the real pellet mill operators all know, that the pellet mill is operating optimum just at the moment before it starts to choke. So now the trick is, how can you find that point? The other thing is, with the linear roll adjustment, you say, yeah, nicely, but I don't want to damage my die because I need to know where my die is. So we have a solution for that with measuring the speed of the rolls. Because when the speed of the roll is the same as the die, there is no slip, we know it's touching the die, it's 0. But as soon as you go a little bit off the die, there is a little bit of slip. And that means that there is no steel-to-steel contact, meaning that your die life is much longer. And how that looks like, see here. So this is the 0 point, and the RPM goes up when we increase the temperature. And at a certain moment, you see that the roll speed is going down. I say, oh, we should not go higher in temperature, because if you would go higher, but one roll will stop. Then the next thing is that you can play with you stop with the temperature, 78 degrees, and then we start to play with the roll distance. And you see that you can control nicely the slip and keep your pellet mill at the optimum point. Talking about dies, I see so many times when I come into a feed mill, the feed miller say, solving his problem of pellet quality by just buying a thicker die. But the thicker die is a curse. It's very sensitive for slippage. You can have less steam addition, meaning with that it reduces your capacity. You get a higher wear cost, your higher energy cost. I give you quite an interesting calculation here, what you can sometimes find in the feed mill. So when you run optimally, you run, for example, at 80 degrees with the 12 kilowatt hours per ton energy input, meaning that you have not so much. You have steam costs, but they are not very expensive, and you have limited electrical costs, but they are expensive. When we do it, for example, instead of the 80 degrees, we go to 55 degrees. You see that the steam costs are reduced, but the energy costs, which are much higher, they are increased, meaning the total costs are increasing. And that is not all, because what is the result? On the let's say the ideal situation, the capacity of the kilowatt hours is 12 kilowatt, but it means that your capacity of your pellet mill can be 21 ton if you have a 315 kilowatt machine. But if you reduce your steam, you consume more energy, meaning that your capacity goes down. So at the end, you run on a very low capacity with very high costs. And with that high energy, you also increase your maintenance cost. And this situation you see happening in the field. Then you're running with a too thick die, you maybe have not the optimum conditioning system there. Talking about dies, people run with the dies till they really are worn. But the economical lifetime of a die is much shorter. Here, look what happens. You see the price of the die, which is very small, goes down, down, down. But the energy consumption of a die in a lifetime goes slowly up. Meaning that the total cost of the die also goes up. Meaning that your economical life is shorter than your technical life. So people, feed millers, don't be penny wise but pound foolish. Change that die in time. Talking about that, even worse is your roll shells. The roll shells are very low cost compared to the expensive die. But what do people? They damage their die with the short rolls, with the cheap roll shells, because running too long. One quick way before we go slowly to the end. Talking about rolls typically need to be greased, but grease is not nice to handle in a factory. You have to store the barrels, you have to go to your automatic greasing system, you have to fill that greasing system, you have dirty hands, it is really a disaster grease. So we offer you the possibility not to use grease anymore because we have grease for life rolls. Those rolls are filled with a little bit of oil. Oil has a better lubrication characteristics than grease anyway. So really the future, and it's also hygienic because the grease doesn't end up in the feed. So we had the linear conditioning. But if pellet quality still is a problem, and you have, for example, a very high fibrous material, you use very thick dies, and still you have no quality, there are other solutions. One thing, and I'm not saying that because I'm selling pellet mills, is double pelleting. It all depends on your formulation. In Holland, England, Ireland, Belgium, you can find a lot of double pelleting installations because we have the entrance to a lot of raw materials. Grains are nearly gone in the feed for cattle and dairy, and in this way, double pelleting is a solution because if it's hard to do in one step, you can do it in two smaller steps. No thick dies anymore. Back to thinner dies, increased flexibility, and much easier pelleting parameters using low-cost ingredients, creating lower production costs. So we went through this story of the different conditioning processes and the pelleting, and then we coming to this pre-compaction side, and basically the last thing is in the area where you have very high quality demands, you also use a lot of energy. For example, pre-compacting with an expander. An expander is a shaft which is transporting the product to the front, and a cone who is stopping it, increasing the pressure there. Now, what I like to realize, everybody, is that if you have a feed where it is very hard to get energy in, and very hard to make a good pellet quality, then on normal pelleting you will end up like here, less energy, but also lesser quality, while the expander pelleting can have a better quality, but also using much more energy. Because if you see in ratios where it is easier to process, where you can still make a quality with a normal pellet, you see the difference. The qualities are the same, but the energy on the pelleting process is much lower than on the expanding process. Much lower than the expanding process. So the story is, and that is basically the story of my whole presentation, you have to use, you can use the expander to improve your quality, but you have to use it on the right formulations where it is hard to get energy in, because if you do it on the wrong ones, you have higher wear cost, less controllability, and it's less user friendly. And of course, the first step, if you want to add fat, is not buying an expensive expander, it's to put a post-pelleting fat coater in. So that basically brings me to the end. There is not one solution for all in conditioning. You have to select your system based on the properties of the material you're processing and what you want to do with it. I always say, hey, what works for him doesn't necessarily work for her. And yes, if you make the incorrect solution, you end up paying too much. So thank you for your attention. I think if there are questions, you want to do it now or you want? Okay, thank you, thank you. It was a pleasure.